this one slide doesn't do it justice, so we're going to do some conversions. Woo! Page 12 in your physics book has got a chart of conversions. Do you remember these from chemistry? How many of you know the power of 10 for kilos? This is an easy one, people. 10 to the third. You had the right number. There's page 12. There's the chart. What I expect you to know, oh, hey, look, how convenient. A former student put little pencil marks next to these because I'm the only person who's taught physics out of these books, because when I started teaching physics, we had a book from like 1991, and I thought we were time for an upgrade. I expect you to know, without having to look it up, these. You know what? Forget Deca. Deca's stupid. Nobody likes Deca. And I expect you to know those three. So, in here we don't use pico and nano as much. When we get to electromagnetism, we will use micro and milli a lot. We use mega quite a lot in here, and we use kilo, obviously. Giga less frequently, but I do expect you to know the name, the abbreviation, and the power of 10. We're going to do a quick refresher on conversions, and then we're going to look at bigger, badder, uglier conversions, because that's really the name of the game in physics. So we did simple conversions in chemistry, so let's warm up with one of those. So we got 726.1 centimeters. We want to know how many kilometers that would equal. It's kind of a nonsensical conversion, but it keeps us within the units I want to talk about. If you haven't been Moserized in terms of conversions, I'm just going to tell you, I got a system. I may sound like an evil, horrible human who's standing over you with a whip to make you use my system, but if you have faith and you follow the system, it really does make your life easier in the long run. Convert everything to scientific notation. Use the powers of 10. They make it so simple that you can do all of these without a calculator. Well, you should be able to do these without a calculator anyway. So always start with your given. You know that, 726.1 centimeters. Always put in the units. I have this weird habit of filling in all my units first, and I know that I want the units down here to be the same as the units on the diagonal and above them so that they cancel. Now, that said, shrinking and moving this over, I want to end up in kilometers. And years and years ago, when dinosaurs roamed the earth, and I was in about the 7th grade, and we did conversions, giga, mega, kilo, we memorized this cute little chart with all of the big prefixes up above and all the little prefixes down below, and there was the base unit right in the middle. And for visual learners, something like this is usually really helpful, because the reminder is, if you're using those powers of 10, the relationship of the power of 10 is always back to the base unit. So therefore, if you go from kilo to base and base to centi, or vice versa, you can use those powers of 10 and make your life really easy. So we always step through the base unit when we're doing these, even if we're staying on the same sort of, I'm putting this in air quotes, side of that little graphic. So I'll get rid of that. And so I know that that unit's going to be meters. I know that meters has to be here to cancel. And I know that kilometers will be there, which will put me into kilometers when I'm done. Now, the power of 10 always goes with the base unit. So I immediately, the minute I set this up, I stick a 1 in front of the prefixed units so that I don't do something stupid. The less time I give myself to screw it up, the better off I generally am. And looking at the chart on page 12, or if you know it off the top of your head, what power of 10 relates centimeters to meters? Negative second. What we're saying there, and in any dimensional analysis problem, which is what these are called, or a factor label problem, the things that we're stacking have to be equal to one another. Because essentially, as long as they're equal, we're multiplying by 1. 1 centimeter is equal to 10 to the negative second meters. What's the power of 10 that relates kilo and base? 10 to the third. So again, these are equal. 1 kilometer is equal to 10 to the third meters. Now, if we're going to do this all in scientific notation, I problem because I've got this 726.1 that isn't in scientific notation. So if I really want to simplify my life, I'm going to convert that into scientific notation. Darn it, before I even start. 7.261 times 10, let's see, 1, 2, times 10 to the second. So now what I've got is something where I can just line up the dominoes and knock them right down. I have 7.261 times 10 to the. And if you need a refresher on math functions with scientific notation, you can link to a video. 2 plus negative 2 minus 3. What does that get us? Gets us negative third, right? 7.261 times 10 to the negative third. Oh yeah, of course it is. Kilometers. Okay. Minus putting the line right through the answer. There we go. Questions, comments? Does this seem familiar if you've had it before? Okay. Now, the catch. You knew there'd be one, right? Yeah. Every time I say, well, that was simple, it's about to get harder. Do you remember what a derived unit is from chemistry? We use them a whole lot in here. Okay, it's way in the early part of the year. A derived unit is a unit made up of more than one SI unit multiplied together or divided by one another. So, for instance, meters per second is a derived unit. Grams per cubic centimeter is a derived unit. Meters squared, area, is a derived unit. Cubic centimeters, volume, is a derived unit. These are all derived units. Oh, yeah, I see. Well, we have to be comfortable doing derived unit conversions in here. It's fine. You'll live. So what if I have 923 cubic centimeters, and I want to know how many cubic meters that equals? How do I set this up? Well, I start with my given. That's fairly straightforward. So 923 cubic centimeters. I know that I'm going to want cubic centimeters on the bottom, and I'm just going to base, so I don't need multiple steps. Cubic meters. And I'm going to put a 1 in front of the cubic centimeters before I can do something dumb. Now here's where we have problems. My question for you is this: what power of 10 goes up there? Okay, I'm going to warn you that this is a trap. Unless you are like 1/10 of 1% of every student I've ever seen, you're going to get this wrong the first time. I screw it up unless I take very careful pains not to. Jot something down. Write down what you think it is. And then I'm going to see if I'm psychic. Anybody write that? Because that's wrong. Good. I'm glad you didn't write that. But that's the most common error. So the thing to remember is that 1 cubic meter is made up of 100 centimeters by 100 centimeters by 100 centimeters. So it's actually 10 to the negative second times 10 to the negative second times, I got to move that, 10 to the negative second. If you wrote 10 to the negative sixth, you're a rock star. You got this. You might have written something else. That's okay. I tend, and again, you will start to hear in what I'm saying about problem solving that I have an elaborate series of devices to keep myself from screwing up. You'll trip over your own 2 left feet. It's fine. I've made every mistake you can. Well, maybe I haven't made them all. I don't know. Maybe I've got new ones ahead of me. That would be exciting. I've made, I think, most of the mistakes you can make in solving most of these problems, and therefore I've figured out a few ways to keep myself from making those mistakes, which I will very happily share with you. I write that 10 to the second 3 times because it's cubed, and my brain processes that. If you are super clever and like far, far cleverer than I, which is entirely possible, and you can skip right to writing that, bless your heart. I screw up. So I write, when it's cubed, I write 10 to the second times 10 to the second times 10 to the second because it keeps me from messing it up. So what do we get? Oh wait, I'm going to convert this to scientific notation. 9.23 times 10 to the second cubic centimeters. So I get 9.23 times 10 to the second cubic centimeters. Noops, leave off the units. Units here are going to cancel. I'm going to end up in that. Times 10 to the second plus -2 plus -2 plus -2. So that's all plus -6. So 9.23 times 10 to the -4th cubic meters. Okay, so that's the slightly harder case, doing a derived unit where you have a single unit that you're working with. We're going to do the trickiest one now, and then I'm going to cut you loose on a practice sheet. For those of you who have not been Moserized, I hand you the paper practice sheet. The answer key is linked in that chapter plan. As you go, check your own answers so you see if you're on the right track or not. So in this case, we're dealing with not only a derived unit of volume, but we're dealing with two distinct units. Again, we're going to put our given in the first box, 1151.2, but there's something a little different we're going to do. We're saying that there are 1,151.2 grams in every 1 cubic centimeter. I don't want to tell you what you're going to do, but I will tell you that I don't think I've ever seen a student successfully complete one of these if they tried to put the cubic centimeters up in the top under the grams. Don't do it. That way lies madness, potentially dragons, we're not really sure. So doing it this way, you can break it up and convert one unit at a time. And this is just you can start with either one. I'll go ahead, I usually start with the top. That's my habit. I don't know why. There's no rational basis, but that's what I usually do. So if I'm doing that, I know grams have to go here, and I know that kilograms would go there. I'm going to quickly stick my 1 there. What's the power of 10? 10 to the third. Okay, now I'm going to go back to here, and I'm going to put my cubic centimeters here. Why are they on the top? Has to cancel. So that's the other common mistake that I have seen. And my cubic meters will go here. Quickly putting my 1 there. How well can I do here? 10 to the -2 times 10 to the -2 times 10 to the -2. And if you want, 10 to the -6. Okay. That gives me 1.1512 times 10 to the third grams. I'm going to go ahead and do the math. 1.1512 times 10 to the third. I have no powers of 10 on the top. So -3, I got that one. Whoops. Minus -6. Note that I wrote the minus -6 because that's one more trap. If I forget to do that, I generally screw it up. I don't change the signs until I finish the problem because that way it reminds me that that -6 came from the bottom and that it was a -6. This is one of the most common sources of error. So I've got 0 plus 6, 1.1512 times 10 to the 6th kilograms per cubic meter. It's pretty dense. Some pretty dense stuff. Questions, comments, concerns? Okay. I'm going to cut you loose on the practice sheet. You work, you check your answers,